Have you ever wondered if it's possible to travel across the universe in the blink of an eye? As we gaze upon the night sky, the twinkling stars and galaxies far, far away, we can't help but wonder about the vastness of the universe. It's an expansive, infinite cosmos, stretching beyond our wildest imaginations. The concept of space travel, of exploring these celestial bodies that exist light years away from us, is nothing short of fascinating. Yet it's a daunting challenge. You see, even at the speed of light, it would take us 4 years to reach the nearest star, Proxima Centauri. The sheer distances involved in interstellar travel are mind-boggling, to say the least. But what if we could find a shortcut, a cosmic detour, if you will? This is where the concept of wormholes comes into play. Picture a tunnel connecting two distant points in the universe, allowing us to bypass the constraints of space and time. It's like folding a piece of paper in half and poking a hole through it, creating a direct path between 2 points that were once far apart. Wormholes, as they're known, are a fascinating concept, a potential solution to the daunting challenge of space travel. They're a testament to the boundless possibilities that exist within the realm of astrophysics and the mysteries of the universe. Intriguing, isn't it? Imagine being able to step from one end of the universe to the other in an instant. So, what exactly are these wormholes we're talking about? To put it simply, wormholes are like cosmic tunnels, a hypothetical shortcut through the fabric of space-time. Imagine folding a piece of paper in half with a dot at each end. Now, instead of traveling across the paper, you poke a hole through it, connecting the two dots. That's a basic visual of a wormhole. But of course, this concept isn't as simple as a hole in a piece of paper. It's deeply rooted in the complex world of theoretical physics, specifically Einstein's theory of relativity. According to this theory, massive objects curve space-time around them. Now, if space-time could be bent enough, it could theoretically fold over on itself, creating a wormhole. Here's where it gets even more fascinating. These wormholes, if they exist, could potentially connect not just two different locations in the universe, but also two different points in time. Yes, you heard it right. It's not just about space, but time as well. This means that traveling through a wormhole could potentially take you billions of light years across the universe in a blink, or even to a different era. However, it's important to remember that wormholes are purely theoretical at this point. No one has ever observed one, and the technology to detect or create them is far beyond our current capabilities. Moreover, even if wormholes do exist and can be used for travel, they would be incredibly unstable. Any attempt to pass through them could cause them to collapse, potentially trapping the traveler in a sort of cosmic limbo. Despite these challenges, the idea of wormholes continues to captivate scientists and space enthusiasts alike. They represent the tantalizing possibility of shortcuts through the vast expanse of space and even time travel. The concept of wormholes pushes the boundaries of our understanding and challenges us to rethink what is possible. That's the magic of wormholes, creating shortcuts through space and time. But how close are we really to achieving this kind of space travel? Let's take a moment to consider the current state of space travel. We've come a long way since the pioneering days of Yuri Gagarin and Neil Armstrong. The past few decades have seen significant advancements in technology, propelling us into a new era of space exploration. Space agencies and private companies have developed sophisticated rockets and spacecraft capable of reaching the farthest corners of our solar system. We've sent probes to Mars, Jupiter, and even beyond the heliopause, the boundary marking the end of our solar system. These monumental achievements have expanded our understanding of the universe, and yet they only scratch the surface of what's possible. Despite these advancements, we're still in the nascent stages of space travel. The challenges that we face are numerous and daunting. The vast distances between stars, the harsh conditions of space, the enormous energy requirements, these are just a few of the hurdles we must overcome. And then there's the concept of wormhole travel. It's a tantalizing prospect, the ability to traverse astronomical distances in the blink of an eye. But it's also incredibly complex and largely theoretical at this point. Our current understanding of wormholes comes from the field of theoretical physics, specifically the theory of general relativity. But translating this theory into practical technological applications is a whole other ballgame. We're talking about manipulating the very fabric of space-time, something we're nowhere near capable of doing with our current technology. Moreover, there are still many unknowns about wormholes. Are they stable? Can they be controlled or navigated? These are questions that scientists are still grappling with. So where does this leave us? Well, we're making steady progress, but we're also acutely aware of the enormity of the task ahead. Interstellar travel, let alone wormhole travel, is not something that will be realized overnight. It requires time, resources, and a deep understanding of the universe and its laws. So we're not quite there yet, but the future holds promising possibilities. Scene script: wormhole travel isn't without its challenges though. Picture this: you're a pioneer, setting foot on the frontier of the unknown, the first to traverse the cosmic highways of wormholes. It's an exhilarating thought, isn't it? But let's not forget the inherent risks and challenges that come with such a groundbreaking endeavor. Firstly, there's the issue of instability. Wormholes, in their very nature, are volatile and unpredictable. They're like cosmic quicksand, ready to collapse at any moment. This raises the question, how do we navigate through these cosmic shortcuts without getting caught in a celestial collapse? Then there's the energy conundrum. To keep a wormhole open long enough for a spacecraft to pass through, we'd need an astronomical amount of energy. Some scientists speculate we'd need the energy equivalent to the mass of a star. As of now, harnessing such immense energy remains a challenge beyond our current technological capabilities. And of course, there's the unknown. The effects of wormhole travel on the human body are still a mystery. Would it be like a Sunday drive, or more akin to being stretched like spaghetti through a cosmic noodle maker? We simply don't know. These are the uncharted territories of space travel, and they come with a host of unknown risks. Despite these challenges, it's important to remember that every groundbreaking endeavor in human history has faced similar hurdles. The first airplanes were dangerous and unreliable, but look at how far we've come. The same goes for the first space missions. Today, we're standing on the brink of a new era, ready to expand our horizons even further into the cosmos. These challenges, while daunting, are not insurmountable. They are the next frontier for us to conquer. And who knows, maybe one day we'll look back on these early days of wormhole exploration with the same fond nostalgia we have for the first flight or the first steps on the moon. But for now, our journey into the wormhole is just beginning. So, what does the future hold for interstellar travel? As we stand on the precipice of the unknown, gazing out into the vast expanse of space, we can't help but wonder what lies in store. The future of interstellar travel is a tapestry woven with threads of possibility, each one more intriguing than the last. Let's begin with the advancements in technology. Today, we're witnessing the birth of a new era in space travel. Emerging technologies such as ion propulsion and nuclear thermal rockets are revolutionizing our approach. They promise to make travel faster, more efficient, and more feasible. Yet, even with these advancements, the sheer distances involved in interstellar travel remain a daunting challenge. This is where the concept of wormholes comes into play. Imagine if we could bend the fabric of space-time, creating shortcuts through the universe. This isn't just science fiction, it's an active area of research. Scientists around the world are working tirelessly to unravel the mysteries of these cosmic tunnels. If we can harness the power of wormholes, we could potentially traverse the universe in the blink of an eye. The implications of such a breakthrough would be monumental. For one, it would open the doors to exploration on an unprecedented scale. We could journey to distant star systems, uncovering the secrets of the cosmos. It could lead to the colonization of other planets, providing humanity with a safety net should Earth no longer be habitable. And then there's the possibility of contact with extraterrestrial life. The universe is a vast place, and it's statistically unlikely that we're alone. If we could travel to distant star systems, we might just find our cosmic neighbors. Yet, all these possibilities come with a caveat. As with any venture into the unknown, there are risks involved. We must tread carefully, respecting the laws of nature and the potential dangers that lie in the unexplored territories of the universe. In the end, the future of interstellar travel is as exciting as it is uncertain. It's a journey that will require courage, ingenuity, and a relentless desire to push the boundaries of what's possible. But if history has taught us anything, it's that we humans are explorers at heart. The universe is vast and full of mysteries, And with wormholes, we might just have a chance to explore it. In the end, the concept of wormhole travel is as fascinating as it is challenging. As we've journeyed together through the mysteries of the universe, we've delved into the enigmatic concept of wormholes, bridges through space-time, potentially offering shortcuts to the furthest reaches of space. We've explored the gritty reality of space travel as it stands today, a testament to human ingenuity, yet still in its infancy compared to the cosmic scales we dream of conquering. We've acknowledged the risks and challenges that accompany this audacious dream, the immense energies required, the unknown effects on the human body and mind, the technological hurdles yet to be overcome. But we've also glimpsed into a future where these challenges are surmounted, where interstellar travel becomes a reality, not just a tantalizing concept. The journey may be long and filled with challenges, but the destination, a universe within our reach, is worth every step.